Broadcast is now starting. All attendees are in listen-only mode.
Welcome, and thank you for joining today's webinar. You will hear from both LonMark International and Western Allied on synergies between BACnet and LON. Please note this webinar is being recorded. Participants are in listen-only mode. If any issues arise during the webinar, please use the chat box to communicate with the organizer. You may submit text questions to our speakers by typing your questions into the questions box of the control panel. You may send in a question at any time, but questions will be addressed at the end of today's presentation during the Q&A session. The webinar recording will be made available on the LonMark website for future reference. At this time, I will turn it over to Ron Bernstein, CEO and Executive Director for LonMark International, to provide an overview and to introduce today's speakers. Ron?
Thank you, Shannon, and welcome everyone. We have quite a large group of people online today. Thank you for attending. I also want to say thank you to our members who made this webinar possible. We'll share a little bit more information about that at the end of the event. Sammy, if you could go to the next slide. So the webinar, as Shannon said, is being recorded. We will take questions at the end. However, during the seminar or the webinar, if you type your questions into the questions box, if there are any technical issues or there's something happening, I will interrupt the speakers and let them know. Occasionally that happens, but hopefully today will go smoothly. So this webinar is being brought to you by LonMark International. LonMark International is a standards development and member trade association. For those who are not familiar with LonMark, we've been around since the mid-1990s, where we've developed control networking technology standards and brought them into ANSI and CEN and ISO for use within the building automation marketplace, within the smart cities marketplace, process control, factory automation, and even home automation. So LonMark is known for interoperability of open systems using a control networking platform called LonWorks. And over the years, LonWorks has developed quite a following for its very efficient and well-orchestrated definition of interoperability and how the devices work together. Over the years, however, other technologies such as BACnet and Modbus and Zigbee and others have come to the forefront. And what we've learned is that end users and owners and integrators prefer having choices. They like having choices between what technology is best for the application. And today's seminar is on the synergies between LonWorks and BACnet, the two prevailing major standards for the building automation marketplace. And one of those, one of the opportunities is to ensure that you get the best of both in these new environments. So today's webinar is going to go through a demonstration and discussion of how BACnet and LonWorks can work together on the same network at the same time and working over different media types, different types of wire and non-wired systems. So it's an exciting time for us. I also want to mention that there are some new standards that are coming out from LonMark. One of them is a new high-definition power line communication transceiver. You'll hear more about that today. There's another one which is a new RF transceiver. This is a native LonWorks RF transceiver for medium range mesh networking. That will be coming out, and hopefully we'll have another webinar on that very soon. We've also just announced back in January the adoption of LON over IP as a native communication media was announced through ANSI CTA as a new standard, and it's going to become an EN standard. It's in the process now, as well as a new web services standard. So web services for IoT applications on top of a standard LON network. So those are a few highlights coming out of LonMark. Let me introduce today's speakers. Sammy, if you can advance the slide. So we have two longtime members of LonMark from Western Allied. Now, Western Allied is a network integration company based in the Southern California marketplace. and one of our longtime supporters, Alan Slobodkin, is with us today. Alan is a partner and vice president at Western Allied, and Sammy Arbid, who is a controls engineer, and Sammy is the chief architect behind today's demonstration, along with some of his other team members. So let me introduce Alan and Sammy and have you guys take it away. Thank you.
Thanks, Ron. I appreciate the introduction, and I'd like to thank everybody for joining us today. Let's go to the next slide. I'm just going to introduce Western Allied, talk a little bit about us, and then I'm going to turn it over to Sammy to give the presentation and the demo. By the way, we are actually a large design build mechanical engineer in the Los Angeles area. And we've been in business almost 60 years. We specialize in new construction retrofits, primarily in the office, commercial. We do a lot of studio work. We do some hospitals, medical. And I joined Western Allied back in the mid-90s to primarily start up our controls division. We have put in, over the years, many systems, including proprietary systems, been doing LON works, BACnet, Modbus systems. We've been in the LonMark organization since early 2001. A few of our customers you'll see are on there. This is just a small portion. A little bit about the company. We really pride ourselves on being innovators and always supporting our customers with possibly the most robust systems we can. We like to get them and keep them. And I think with that now, I'd like to turn it over to Sammy to where we could get into the presentation and the demonstration, because we think you're going to find this very exciting. I mean, we have, and we're very enthused about this. And with that, it's up to you, Sammy.
Thanks, Alan. So LON and BACnet together. This is not going to be a session where we argue the pros and cons of these protocols. We've heard those arguments for years. No, instead today we're going to be talking about the benefits of the two. And we think we have something really exciting. We think there's an opportunity where these two protocols can actually be combined for their benefit. And I think you've all heard the phrase disruptive technology in the past, and I believe we're about to witness something disruptive. So what we have here is what we call a multi-protocol controller. With it, we can talk 3 protocols simultaneously or individually and do some things never before possible. So it can communicate over LON over free topology or FT. It can communicate BACnet IP over FT, and it can communicate BACnet to MSTP over RS-45. And it can do it simultaneously, or it can do them individually. And with that, it gives us the ability to read and write to a single point on a controller. And that's all done without the use of gateways or any kind of proxy point. It's pretty phenomenal, and we're going to demonstrate it later today. It's surprisingly simple once you see it. And all this is actually achieved by merging the BACnet and LON OSI stacks. And I'm not sure how many of you are familiar with the OSI model or the Open Systems Interconnect model. We did a seminar recently, and we asked the same question, and we got a lot of blank stares. So we're going to actually talk about that a little bit, give you guys an example, maybe a real-world example of something you're familiar with OSI. So the OSI model is a standard communications model that was developed in the 70s to assist in standardizing communications, as well as making them more adaptable and easily to change as technology progresses. And it's essentially developed with 7 layers or 7 different aspects of a communication stack in mind. This is an example of a web browser. and the communication stack's used to communicate with a web server to navigate the web. So from the bottom all the way to the top, we have layer 1, which is the physical layer. In the physical layer, we're taking the electrical impulses and converting them into zeros and ones. And we do that today using Cat5 or over the air for Wi-Fi. After that, we move up to layer 2, which is the data link layer. This is where Ethernet is implemented. And Ethernet is really just used to route devices on a local network between, let's say, your laptop and your router. After that, we move up into the network layer. In the network layer, we have IP. You guys are probably all familiar with IP. You know, you've heard of IP addresses. IP is the internet protocol. It's used to route packets between networks. So this is how a packet gets from your network out to a remote network. After that, we have the transport layer, TCP, and you guys have probably heard of the TCP IP protocol suite. So this is the TCP portion of that. TCP is responsible for handling reliability. So what happens if that packet is corrupted on the way out to the internet, or you know, is just never delivered for any reason? Well, TCP is responsible for retrying that and making sure that the delivery happens. After that, we have the layers 5 and 6, the session and presentation layers, and those are implemented by HTTP. HTTP is really responsible for making a connection to a web server and defining what that connection looks like. What kind of request are we making? And what's the metadata associated with the request? What kind of query parameters are there? What's the body of the message? And standardizing what the body might look like, stuff like that. So everything gets passed up eventually to the highest level, layer 7, where your web browser or the application layer then presents all this to the user. So that's a simple example of web browsing. Now let's look at how this is actually used with LON and BACnet. LON and BACnet both implement the OSI model. They have OSI stacks. And it's essentially said that if a controller implements the LON stack, the LON OSI stack on the controller, that it's native LON. And likewise, if the controller implements the BACnet stack on the controller, it is native BACnet. And if you look at the two stacks, there's actually some similarities, especially on the physical layer. Physical layer is identical. We have twisted pair, we have Wi-Fi, we have Cat5. Okay, so both stacks have the capability of using the same physical media. Great. Next, we have the data link. Now we have a couple of small differences. In LON, we have FT, which we're going to get into. That's free topology. We're going to be talking about that at length today. And then we also have Ethernet and RS-45. Well, BACnet has MSTP. You guys might be familiar with that. And Ethernet and RS-45 as well. Moving up the stack, LON has Neuron ID defined in their layer 3, and BACnet has device ID. So those are just network addressing schemes. And we keep moving up. BACnet does not actually implement anything on layers 4 and 5. It's fine, and those are, you don't have to implement every layer. It's really just there if you need to implement something. So going up to layer 6, presentation layer, this is where in LON network variables are defined and BACnet objects are defined for BACnet. So all that eventually gets consumed into a controller application, and the controller can then speak LON or BACnet natively, depending on what stack is available to it. Now, so what we've done here is we've actually merged the two stacks under one. And it gives us the flexibility to now communicate both LON, BACnet IP, and BACnet MSTP over various physical media. So we can, for the first time now, speak natively in all three protocols, LON, BACnet IP and BACnet MSTP. Pretty phenomenal. Now, with the MT controller, if you have all these protocols available, certainly you would want to be able to expose them on variables in a controller. So any variable that's in a controller can be exposed on any one of these protocols. You can pick and choose, or you can do all three. But even if you do multiple, it is still just a single variable. And we're going to demonstrate this later. You'll see it. It's pretty cool. Again, we're not using any gateways for this. You know, all of this is happening using native LON and BACnet communications. So we have a little diagram showing the system architecture of our demonstration here. If you look in the middle, we have a couple of devices labeled MP controller. And something a little bit unique about them, they have two communication trunks on them. They have a MSTP RS-45 trunk. If you follow that, it goes to a BACnet device. I'm sorry, a BACnet gateway. That BACnet gateway in our case is just the Tritium Jace. If you follow the other communication trunk, the one labeled multi-protocol FT, free topology, you'll notice it goes to a BACnet IP over FT router. Now, what is that? That is the Echelon IZOT router. Now, the router is really just taking BACnet IP from Ethernet and putting it onto twisted pair free topology bus. It's the first time we've seen BACnet IP from Ethernet go onto a twisted pair. And it's actually pretty phenomenal. And this also works in reverse, of course. So any BACnet IP from a twisted pair can traverse onto the Ethernet network as well. So what we have here is actually an IP communications on multi-drop. So what is multi-drop? So multi-drop is a single electrical connection that connects to every controller. There's no requirement for network switches. There's no requirement for routers or hubs. And essentially all the controllers, they're physically connected on the same bus. That bus can be a daisy chain bus. It could be ring topology. It could be a star topology. It could be anything, right? So we call it free topology. And this is the first instance of a IP-based communication on multi-drop bus. Up until now, IP has always been done over Ethernet. So what are some of the advantages that we get with BACnet IP over FT versus Ethernet? Well, firstly, no switches, no routers, no hubs. That's great. Instead of dealing with the limitations of Cat5 and Cat6, which can only run 100 meters, you can now go 5,000 feet if you're in a daisy chain, or you can go about 1,500 feet in free topology. It's much lower cost. You don't have to run Cat5 cabling everywhere. You don't have to home run all these cables. You don't have to worry about RJ45 connectors and did they get crimped on correctly and testing them with Ethernet connectors and testers. All that kind of just goes out the window. It's much more reliable. If a controller goes down, you don't lose everything downstream of it. You just lose that one controller because, again, everything is connected, physically connected onto that one bus. IP addressing. I don't know how many of you guys have had to work on large building automation networks, but if you were to walk into an IT manager's office and let them know that you're going to need about 500 IP addresses to build your next network, he's going to have a fit. So using a multi-drop solution If you're using a managed network solution with it, IP addressing is automatic. You don't have to request anything from the IT manager. VBMDs. We don't require VBMDs actually on this network. So VBMDs are usually used in BACnet IP to traverse across Ethernet routers. So we don't need any of those. And it helps eliminate the possibility of Ethernet flooding. So BACnet IP uses broadcasting on Ethernet. And since this is actually a discrete network, it's completely separated from the building's IT network. Those broadcasts never actually traverse onto the customer's network, which definitely has been painful for many customers. We've heard several complain about that. So let's talk about what FT is for a minute here. So, or free topology. Instead of using RS-45, FT uses what's called differential Manchester encoding. By comparison, BACnet MSTP uses RS-45. RS-45 relies on the differential of two voltage levels to determine if a packet or if the data value has a 0 or a 1. So the amplitude of the voltage is what defines if it's a 1 or a 0. On the other hand, differential Manchester encoding is really just looking at pulses, at the change of a pulse in the wave stream determines if it's a 0 or 1. The simplest way to think about it is really kind of comparing it to AM and FM radio, where RS-45 is very similar to AM radio, where it's relying on amplitudes to define its zeros and ones, whereas Manchester encoding, differential Manchester encoding, is relying on the frequency changes, frequency modulation, which is FM. So what are some of the benefits of FT and differential Manchester? Number one, it's polarity insensitive. You can flip the conductors in FT and differential Manchester, and it still works. RS-45, on the other hand, is polarity sensitive. You have to land the correct conductor on connection A on 500 devices. If you mix one of them, the bus goes down, and likewise for the other conductors. It's significant, has significant noise reduction. So since we're not really changing the voltage levels, we're not really concerned if the level goes a little high, which can happen with noise. So definitely some better noise tolerance. Bus loading in RS-45. So bus loading is very important in RS-45. It actually limits the number of devices you can put on an RS-45 bus. With FT, there's no concern with bus loading. The problem goes away. FT has a very simple cabling methodology. It uses a two-conductor, shielded or non-shielded wire. And like we said before, you can just land the wires in any polarity. It doesn't make a difference. You don't have to terminate any shields if you don't want to. Sometimes in RS-45, you have to worry about something called biasing and floating grounds, and even traversing the communication bus between buildings. We've had numerous headaches with RS-45 going between buildings and dealing with grounds. And I don't know how many of you guys have had to deal with that in your installations. It's a very common problem. And with FT, you really don't have to deal with floating ground issues. It's very fast. And in fact, it's used in magnetic storage like floppies and hard drives. So on the other hand, we have MSTP. So let's look at what MSTP is a little bit. MSTP is known as master-slave token passing. It requires request-response communication. So we have a master device who needs some information and requests it from a slave. The slave then responds back with the information. The slave never spontaneously gives in any information. It has to be requested of it. So, and that's what we call request response. Multi-protocol over FT can do request response as well, but it can do, in addition, it can do direct messaging, where controller A can send a message directly to controller B without being asked for it. It's extremely reliable and requires no masters or slaves. And so with that, we can essentially combine the two sets of protocols into a synergistic protocol suite. And all of these protocols can then access a single data point in a controller. And we're going to show you guys that in just a minute here. So before we get into the demo, we want to talk about a little bit of what we've set up here. We're going to show you guys the ability to use any combination of BACnet IP, BACnet MSTP, and LON. And we want to also demonstrate the capabilities of direct messaging and what that really gives you, what the performance of that really looks like, and it's pretty phenomenal. Let's look at the demonstration board. We have a picture on the right showing a number of controllers and devices. There are some green and blue and white devices. Those are smart controls multi-protocol controllers, and that's where our logic is going to reside for some of our testing. Those will support all the three protocols: BACnet IP, BACnet MSTP, and LON. Above that, we have a typical JACE, and that's going to act as our BACnet MSTP master. Next to that, the white device, we have that's our Echelon IZOT router that's going to basically route from FT to Ethernet. Down in the bottom corner, the black and orange device, that is a Circon VAV controller. It's actually also multi-protocol. So we have multiple vendors providing multi-protocol protocol capabilities. And so that's kind of a real-world HVAC application and for multi-protocol. Now, we also have something, a new technology. Ron mentioned it a little bit ago, high-def power line carrier product that we're going to be showing you guys as well. It's going to require a router and a power line bridge and then a controller. And we're going to show you guys the performance of communication over power line using this phenomenal technology. So with that, I think we need to break out of this presentation and let's go into a live demonstration. So here we go. Oh, there it is. Okay. So first things first, I want to show you guys in Niagara what this network essentially is consisting of. We have, oh, here we go. So we have a BACnet IP network with a number of devices. These two are the smart controls devices that we had pointed out. This is the Circon VAV, right? So these are communicating BACnet IP. You can see their device IDs over here. You can see their MAC addresses. This is the LON network on the other hand. And here you go. Let me close this. This is the same thing. We have, smart controls devices. We have the Circon VAV. And oh, let me actually go back to the BACnet IP. And all of these are just discoverable. You click on discover, and it just finds everything. It's actually rather quick. So that's it. It discovered those devices, and at that point, we would just drag and drop them into the database or click the Add button. Similarly, in MSTP, here's our MSTP network. I'm just going to discover MSTP. Go. And there we go. Those are the two devices in MSTP. Okay, so let's look a little bit under the hood and see what's going on with some of these devices. We have a web page here. Actually, let me go back. So we have a web page with showing some data points on a controller, with the ability to read and write using the various protocols. And on the right-hand side, we have those that data point shown in the actual application. This is actually a single data point in the application that is implemented as a float and exposed in both BACnet and LON. What does that mean? So if I click on this, you'll see here that we can define this as a BACnet object. We called it an analog write, and we gave it an analog output type. It's an AO. And we also defined it as a snippet type in LON. We called it iAnalog. Similarly, we have an output device. This is a read-only point, and we defined it as a BACnet object, as an analog input, and as a LON network variable, O analog, we called it. And those are exposed onto a web page where we can read and write them simultaneously using any one of the protocols. Let me demonstrate that for you. So using BACnet IP, for example, I'm just going to, give it a value of 123 and hit save. You'll see immediately in the controller it changed to 123, and then the web page, updates, a little bit behind that. But immediately it changed in the controller. I'll do the same thing with MSTP. Let me give it a value, just something. Hit save, and there it goes. Boom! It immediately went to 987 in the controller. Let me try that again. I think I typed it wrong. Okay. There we go. And we can do the same thing with LON. Oh, let me wait for it to update here. Okay. And we'll do the same thing with LON. I'll do, let's do a value of 100, let's say. There we go. So this is writing to a single native point in a controller using BACnet IT, BACnet MSTP, and LON simultaneously. Pretty phenomenal. Okay, let's have a look at, should we go over to the FT demo?
Or show them the Circon VAV.
Oh, the VAV controller, yeah, that's good. So for the VAV controller, let's pull up the camera real quick. You guys can see this VAV controller in action. So down here, we have a VAV controller. And damper position is currently at 50%, more or less. And we see a space temperature value and some, analog input, a temperature that's taken in over the network, essentially. And I can override the damper position in either BACnet or LON, if we like. I can click here, and let's say I'm gonna go full open. I'm going to do this over BACnet IP. Hit save, and I don't know if you guys can see it, but in the camera, the VAV damper actuator should be opening. Yep, it looks like it's turning clockwise. It's great. And the damper position on the graphics is updating as well. All right, I'm going to, let's say I'm in LON, I want to close it. I'm going to go to 0. So here we go, here's LON. Yep, now it's going counterclockwise. It's closing. Very good. that's a real world application for HVAC. Very simple. Next, we want to kind of get into one of the benefits of ST. So, as you know, MSTP and BACnet IP are traditionally polled. And so what we want to do is kind of demonstrate what if we were to use direct messaging for BACnet IP in a lighting environment. So what we have here is a couple of buttons. The network button at the top is actually hardwired to this controller, and when we press it, the controller will actually signal this lighting controller, which is wired to these lights, to turn on or turn off the lights. We also have a local button over here, which is hardwired to the lighting controller, which will turn on and off the local light. You know, just to demonstrate a hardwired kind of a real-time lighting switch. So, and you'll see when we press this network button, the latency to turn on the various protocols varies. And what we found is that FT is almost, I mean, just real time. You can just hammer on this thing, and whereas MSTP and BACnet IP, because of polling, are not really that responsive. And we can even hit the network and the local buttons simultaneously, and you really can't, oh, let me actually get them in sync with each other, of course. You can't really notice the difference between a hardwired and a network connection when using FT, thanks to direct messaging. So, and let's see what those timers actually look like here. That's actually hammering it after a while too. So it looks like, let me turn this off again and back on. Yeah, let me clear them. Waiting for the graphic here to update. All right, very good. So boom, the FT immediately takes off. So there we go. So we basically see FT, you know, turns on the light within 10 milliseconds. MSTP takes about 2 seconds. BACnet IP in this case took about 3 seconds. And you know, BACnet IP and BACnet MSTP, they go back and forth between which one wants to take longer, depending on where it is in its poll interval. Let's do that again. Come on. Wow. Yeah, and sometimes it's really slow. I mean, oh yeah, there we go. In this case, MSTP fired in less than 10 milliseconds. Our timers didn't even catch it. That's why it's showing a 0. 8 seconds there for MSTP and BACnet IP.
So time to show the HCPLC.
Oh, that's right, of course. So, power line carrier. We have a pretty interesting set of devices here. Let me see if I can move these into the camera. So, what we have here, let me get the web page out of the way. Let's go full screen on the camera. There we go. That's better. So what we have here is a LON router by BACnet, and with it, an HDPLC bridge. This takes communications over Cat5 and puts it onto a power line carrier. And then on the other side, we actually have a little controller, little demonstration kind of controller board, and this receiver for it, which is just connected on power line carrier. That's it. There's no other communication bus on this. Whatever powers this is what's actually carrying the communication. And you'll see a little light on this board that turns on when we hit the network button. and just look at how fast it fires. I mean, it's just as fast as the FT light. Phenomenal. And this is actually happening over power line carrier. This could be plugged in, across the building, just running over the building's power line. Phenomenal. So I think what we showed you guys is actually, pretty revolutionary. These are not, things we've been able to do in the past, and we're really interested in progressing with these and using them in future projects.
And Sammy, talk about the fact that these controllers are new, but we've been installing them now for how long?
Oh, right. So the smart controls. Ron, Shannon?
Yes.
Yeah, hi. Thank you, Sammy. Thank you, Alan. Just at the last second there, I lost audio control, so I'm back in. Sammy and Alan, I think that was an excellent demonstration. I want to call out a few thank yous to the folks at Smart Controls, Adesto, Echelon, EBAC, and Circon, Vicon, and Gesatec, as well as the folks at Megachips, who are the core producers of the high-speed HDPLC power line. So at this point, you can start asking questions in the question box. A few of them have come in early, but go ahead and type in your questions. A couple of things that I just wanted to mention on the technology. So some of you may know that the BACnet protocol spec, the SPC 135 spec, actually has 5 different transport mechanisms. One of those, obviously, there's BACnet MSTP, there's ArcNet and Ethernet, but one of those is LON. So LON is actually built into the BACnet spec, but we've never really seen until now implementations of BACnet over LON. And the FT, the free topology transceiver, or the ANSI CTA 709.2, if I remember right, is the free topology transceiver. It's also an ISO standard, is really the core of what LonWorks has been using in the buildings market for the last 20 years. And you saw the benefits of FT being very fast, free topology wiring. So one of the first questions that came in was the question of speed. I think you covered the speed pretty well. But Sammy, what do you happen to know how many packets per second you can transfer over LON FT or now BACnet FT?
I think it's about 80. I think you can go about 80 packets, 80 to 100 packets a second. Yeah.
Yeah. So you're seeing sub 10 millisecond response time, which is in that range. Yeah. So if you're doing acknowledged service, it's about half that. Unacknowledged service is up around 180 packets a second. So depending upon what kind of service you're using. So let me go to pick up. Oh, so before people start dropping off, I wanted to mention I am going to post right now in the handout section. The folks at Western Allied have created a white paper handout on the topic of LON and BACnet synergies. So I'm going to drop that into the handout section now. So let's see, that should work. All right. Can you guys confirm you just saw that in the handout section? Alan, Sammy, Shannon, anybody see that?
Yep, I see it here.
Okay. All right. So while we're talking here, you can download that. I didn't want to put it up there earlier. You'd be sitting there reading through a multi-page white paper, but feel free to download that and take a look at some more of the details. So let me go through a couple of the other questions. Let's see here. So question on how is the wiring of BACnet IP over FT? So you talked a little bit about that. Can you go through the wiring of BACnet IP over FT?
Yes, absolutely. In fact, probably the best way is just to look at what we have here. So the wiring for BACnet IP, let's say starting on the Ethernet side, has a Cat5 connection, and it goes into a router. The other side is just twisted pair 2-conductor. This twisted pair 2-conductor wire, here I'm trying to pull it out so you guys can see it a little better. This 2-conductor wire is actually carrying BACnet IP. It's 2-wire, it's 22 gauge, unshielded, twisted pair wire. Nothing else to it.
Non-polarity.
Yeah, it's non-polarity sensitive. In fact, you can see it on this side. Maybe this is a little bit easier to see. This twisted pair wire here, this blue and white. So that's it. And it connects onto 2 terminals, and you can land any color onto any terminal. It doesn't make any difference. Flip it one way on one controller, flip the other way on the other controller, still works.
So I think the question is really related to when you think about IP, most people think about IP, TCP IP over Ethernet. And we're really taking IP as a transport part of the protocol. We're moving it up and just putting it over a twisted pair wire and still communicating the same message over a different media type. Just like you can use IP over Wi-Fi. There's not a media, hardwired media. It's the same model. So I think that was the crux of the question.
That's exactly right. Let's go back to the OSI model for just 1 second. If you go back here, you notice on data link layer number 2, Ethernet and FT and MSTP and RS-45 all exist on the same layer. You can interchange those. You don't have to have Ethernet with IP. You can have FT with IP if you like. Layer 2 can get substituted for any one of those technologies. And so that's exactly what's been done. Ethernet has been removed from the IP stack, and instead FT was used.
Okay, let's. I've got another question here. In BACnet, there's this concept of change of value. So instead of having to do polling, you can do push through change of value.
Yeah.
So the question is, is it possible to do that as well with LON plus BACnet stack that you talked about?
Yes, the MP stack does support change of value, but we find that change of value is almost never done in real-world applications. So what we try to do is model a real-world demonstration, but certainly yes, it does support change of value.
So in the world of LonWorks, we talk about bound messages, and we do network variable updates via as a peer-to-peer versus the master that does polling and then pushing. So in the world of a combined network, it sounds as though you guys can do both, but probably would do more polling than you would do change of value. Is that correct?
I think no. I think in our case, we would be doing direct messaging more than anything. So change of value has some problems. It's not the best solution in terms of reliability. it actually makes no guarantees of reliability. It's really meant to broadcast large amounts of information up to, supervisors and data loggers and stuff like that. Whereas direct messaging can do that, certainly, but it also gives you a high level of reliability for device-to-device communication, which is not really available in BACnet today. If you want high reliability in BACnet, you have to poll, and then you introduce latencies. So FT and direct messaging really kind of solves that problem for BACnet.
Okay, so another question, let's see, what other VAV controllers are compatible using FT protocol? So that's one, I can reference the LonMark website that you can download a list of all of the VAV boxes that run on FT, and there must be at least a dozen. Most of the major companies have a VAV box. I haven't looked at the list recently, but there's at least a dozen different manufacturers of VAV boxes using LON FT. Now, as far as BACnet FT, I only know of, and do you guys know of anything other than the Circon EBAC controller at this point?
Smart Controls.
Smart Controls?
Smart Controls has a VAV controller.
Ah, okay, so there's two sources for BACnet over FT controllers, and we've seen interest at the last ASHRAE show. We've seen interest from some of the other manufacturers to implement that strategy. So that's a good piece of the puzzle there. Something I also want to mention, part of the challenge of creating an interoperable system is ensuring that when someone builds a device, no matter what protocol it's used, it has all the hooks and all the pieces in it for interoperability. And one of the things LonMark does as an organization is tests and certifies devices for interoperability. You may have heard of things called plug fests or working sessions to check out and prove interoperability. LonMark as an organization has never held one in 25 years. We've never held a plug fest because the certification process and the definition for certification is very well understood, and there's a very robust certification tool that checks out everything needed to verify. And right now there's just about 1,000 devices who have gone through that certification process and have been certified as interoperable. So the process is fairly straightforward. It's a very well-defined specification and set of requirements. So a question people might ask is, are we going to certify BACnet over FT device, over LON FT? And we're working on that as a plan. And if there's interest in that, we can extend our network certification tool to encompass multi-protocol. So it's something we're considering. All right, let's move on. We've got a couple other questions. Let's see. So this is an interesting question. What prevents conflicting commands between someone commanding from the LON side and the other and the BACnet side? Does that make sense, Sammy?
Yeah. So it's a last command system essentially. So the last command, whether it's BACnet or LON, whichever comes in last, is the one that writes to the value last, right? So if you need to guarantee against that, then you need to start applying overrides and stuff like that. And usually all that is handled up at the HMI level, not down at the controller level.
Right, okay. Let's see, question about, is BACnet over FT support IPv6? What's the support? And maybe talk a little bit about IPv4 and IPv6, what the differences are so people understand that and maybe adjust that question.
Yeah, so IPv6 is just it's a much larger address range for IP. It basically quadruples in terms of the number of bits available, which means I think the number of devices
goes way up.
It goes way up. It's exponentially up. but whether or not it supports IPv6, I don't remember.
But
that's actually a good question for Adesto.
Yeah, I believe it does, but again, we're not the manufacturer. We install and integrate. I do believe it does. I know there was discussions about that.
Yeah.
We'll have to look into that one. And if anybody from Adesto is on that can answer that, if you would send me a chat in the chat box, then I can share that with everybody. So again, core technology here, Adesto has done some of the work on this work for the combined multi-protocol stack. I also call out Megachips, who's the core technology for the HDPLC. So we have some of those folks on the call here. If questions come up for them, we can have them chime in. All right, let's go to the next question. We've got a bunch more here. So what do I need if I have a typical BACnet IP device with an Ethernet connection to connect to FTIP? So to connect to, I think, IP over FT using BACnet, what do you need if you have a typical BACnet IP device?
Yeah, you need an Ethernet to FT router. So there are a couple. I'm going to try to adjust the camera so you guys can see it maybe a little better. So that's the one we're using. That is the IZOT router by Echelon. There's also a router that's made by Oxidolene that works as well. And in fact, it has multiple FT channels, multiple FT trunks on it, if that's what you prefer. So yeah, there are a few different options available to you, but all you need is a router. You can take Ethernet on one side, you can get FT on the other.
So I think another answer to that question revolves around if a manufacturer is looking to embed a multi-protocol model into their device. There are chipsets available with the multi-protocol stack that you can implement within a core device, such as what Smart Controls and EBAC has done.
Mm-hmm.
So that core technology right now, you can let us know and we can point you in the right direction. You get that from Adesto and potentially others as they build them out. I think Acetylene and Gesitech are also working on some stack options for that in different protocols. All right, let's go on to the next question. Okay, I guess along the same lines, it's with what effort is it to expect in order to turn a LON device into an MP device? I think we just handled that. In essence, you'd need to incorporate a multi-protocol chip set into your device and build out your product using the FT transceiver, and if you wanted to also, such as the one device, have both FT and MSTP, you need an RS-45 chip, you need the LON FT chip and transceiver built into the product. So I think that...
and Ron, as long as they incorporate the combined stack, they could really use any processor. They do not have to use, whether it be the Adesto 6050 chip. They could just use, as an example, an ARM processor. So, yeah, it could be done either way.
Right, exactly. Okay, more questions coming in. So this is a long question, multi-part question. Have you used IZOT router in a real project? Does its BACnet function work properly in a real project? We used it in projects and they all failed and always down when using BACnet function. Have you met these issues?
So early on, we had some of those issues with the IZOT router, but we were able to resolve those rather quickly. They're working today on multiple projects. In fact, we can even show some examples of ones that have been working, nonstop for months. So yeah, we have them working.
So I remember you guys showed some real project user interfaces. I'm not sure while we're talking here if you have the ability to go to a real project, log in, and show a real project with some of this capability. Is that possible? I'm asking
Yeah, that's
you here while we handle a few more questions. So I also want to point out that it's now 9 o'clock. Normally we set the webinar for an hour. So I'm going to formally wrap this up, but don't go away. We're going to stay until we get all the questions handled. There's about 6 more questions that have come in. But I wanted to make sure you all know that the webinar is recorded. We will give us a couple of days. We'll post it up on the website. All the registrants will receive an email to your email address with a link to not only the webinar, but the slide deck that was used, as well as the handout that was used. So we'll post all of that later this week. And let me turn it back to Shannon. Was there any other wrap-up that you wanted to do? We're going to continue with questions, but I see people are starting to drop off.
Yeah, no, just wanted to thank Ron, Sammy, Alan for the presentation today. As Ron mentioned, we will be in touch with an email once the webinar is ready to be downloaded. And, we encourage you to continue to engage with us on social media via Twitter, LinkedIn, etc. And with that, just be on the lookout for future webinars that will be taking place throughout the rest of the year. And with that, thank you.
Thank you all, and we'll continue. Sammy, maybe you can go to the next slide. I think there was some links in the next slide. Yeah, so we'll have the slides available. You'll all get an email with a direct link to where you can get access to them. And the next slide, I think there was one more. Yeah, so we've got some social media links as well. Okay, so let's continue on with questions. So you were talking about some real-world applications. Let me do another question while you're bringing that up. So there's a question about LonWorks and BACnet and market leadership and who's winning, who's losing, and all that. I think that in general, LonMark has been working on some new core technology that goes leaps and bounds above anything that's out there, and at the same time also working towards embracing choices and flexibility. So we know that a lot of consulting engineers like to write specifications and call out the protocol in a single paragraph in a spec and say, the system shall be LON, the system shall be BACnet. But without a whole lot of detail behind that, it's very hard for an integrator to resolve some of the core technology issues. So with this combined protocol and this combined option, specifications that require BACnet at maybe the high end can also use FT at the lower end as and still be compliant with the spec, but using the best of LonWorks. So I think that's part of the objective here in some of the new technology, as LonWorks has had a very, very strong showing in multi-protocol and multimedia for a long time. We've used twisted pair, power line, radio frequency, fiber optic, and even other transport media, whereas in the BACnet world it's been mainly MSTP and now IP. So there's some advantages to LON. We're not saying that LonWorks and BACnet are going to go their own ways. I think there's going to be more convergence. We'll see over time as more people implement this type of strategy that the folks on the call here have shown you today. So I think that sort of addresses that question. Let's go on to the next one. So question about what is the priority array which is implemented in BACnet for every writable value? Sammy, are you familiar with how the priority array works?
I am in general with BACnet, but I'm not really sure how it was implemented in this stack. I'm not sure how they handle that. That'd be a good question for manufacturers.
Yeah, we'll have to put that one on hold until we get a response from some of the Adesto guys as to how they implement the priority. So LonWorks in general has a priority channel built in as part of its configuration, where you can reserve a series of timer slots in that Manchester encoding for priority messages. So that is part of LonWorks. I think in the BACnet side, there are alternate ways. Again, the priority in the low level, at the media level, for media access is done differently between MSTP and FT, and consequently different for LON and BACnet. So I would have to refer that back to Adesto as to how they manage that inside the controller.
Hey, Ron. So
Yeah.
Sammy is now online with one of the jobs. Yeah, in fact, he launched the Niagara supervisor of the Jace.
This is the Jace.
It's the Jace.
Yeah, I connected on the Jace right now. And so we've actually pulled up a list of devices and went into one of the devices and just discovered all the points on it. So this is a list of discovered points from over BACnet IP over FT.
Okay, and so in this architecture, you've got both LON FT and BACnet FT?
That's correct.
Correct.
Yep, okay.
On the Jace, we've only
We're only using BACnet.
yeah, on the Jace, it's only BACnet IP. That's right. We do have a smart server as well, which is being used for the LON side. So we're doing both. But yeah, so what we're looking at over here is just BACnet IP.
And was there, I mean, this is a question for me, was there a fundamental reason why in this particular end user's requirements that there is both LON and BACnet in the same system?
They basically require that every site have a Jace that gets connected back to their supervisor. I don't remember, did they specify that Jace must talk BACnet? I think it does.
Yeah, I think they wanted to talk BACnet.
They specified that Jace have to talk BACnet.
Yes.
That's what it was. And we were not going to do MSTP, not if we had a choice in it. So this was an obvious solution for us.
So when a specification says you must have BACnet and talk BACnet, and now you can talk BACnet FT to solve all those MSTP nagging issues, you're able to accurately respond to a specification, but still taking advantage of the best technology.
That's exactly right.
Yeah.
And it solves the problem for us because our technicians are LON-oriented, so they can still go out on the job. They can still do all their LON-oriented work. The customer has a BACnet network, and it ties into their BACnet supervisor. Best of both worlds.
Okay, next question has come up. What do you think will be the availability of the new controllers in the market? So let's talk about that one for a second. So all the controllers you saw in the demonstration are available, and you can buy them now. The link to them is on the slide deck that you showed. So there are a few, and we expect more to come. And the second part of the question, and do you think the BACnet manufacturers would embrace this MP technology? Well, let me answer that from experience of what happened at the last AHR Expo show a month and a half ago. This was demonstrated there live, and most of the major companies came to, their product development team came to see this demonstration and talk with the technical team about the benefits and the technology and how to implement this. So my guess is we're going to start seeing more multi-protocol implementations of product over the next 12 months. Sammy, Ellen, you guys talked to quite a few people at the show. What was your general impression?
Oh, I think there's certainly interest. Yeah, I mean, we've had such good luck with it. It has been just a phenomenal controller for us. And I think every job we're doing now going forward, we're using multi-protocol controllers.
Yeah, it's kind of become our go-to solution.
Yeah, it's our standard now.
So I think one of the questions people will ask is, well, how do I get started in this? Where do I go? What can I do to try this out on a first project? What would your response to that be?
I think they could contact certainly smart controls. Again, we're not a manufacturer. We're installing and integrating. So, we've been using smart controls for many, many, many years. They're probably coming up on 20 years now. And they've been just an outstanding company to work with. I think if somebody's interested, they can certainly get in touch with them. And, we also, in all candor, tend to work with folks who are local so we can cooperate. So if there's somebody who's in the area, we put on training classes frequently, and would be more than happy to help people sort of get their feet wet.
That's a great offer, and I think maybe putting together a set of data sheets from all the products and posting it up where the webinar is going to be posted will be helpful. So I'll take that one on. So you'll be able to get data sheets and contact information for all of the products that were used in the demo. I think that would be a very helpful piece of the puzzle as well. So there's some bits and pieces that would be helpful to understand how to do this. All right, let's move on to the next question. We've got another 4 or 5 more here. So there's a question from Lewis about ConnectX. So ConnectX is a company that has helped Adesto out with some of the BACnet protocol stack.
Yeah. Yes.
How is ConnectX involved? Are there software involved? Are you familiar with that?
I just know that ConnectX and Ed has been very active, supporting them. Again, we're not on the manufacturing or that development side. I think the folks at Adesto could address that, but we do know Ed. Ed actually assisted us on a project which was MSDP that he and one of our technicians spent about a month troubleshooting an MSDP job. So, but as far as his involvement, I'm not sure. I do know he has been involved, but I just don't know to what extent.
Okay. Yeah, and I've also talked with Ed and been very involved with early on in some of the discussions about how to implement this and where in the protocol in that ISO stack this all need to happen to make it work. And I'm very happy to see that it's now active and live in real products. Which goes to the next question, which is, are these products openly available on the market?
Yes. Yep.
So one of the issues that's always happened in the market is when you have an open protocol or an open system, is that sometimes the products from the suppliers are not openly available to anyone through distribution. They tend to, sometimes in the past they've tended to be a branch only or a partner only, and you can't buy them from a distributor. LON works for.
No, you can. You can buy all these direct. Smart controls. I know smart controls. Their only restriction is a resale license.
Right.
As long as the person purchasing has a resale license, they're more than willing to sell it. We have a number of customers who buy the product direct.
You're talking about your end users buying the product.
And we assist them, and if they need it, if not, they do it on their own.
So that's really the definition of an open system or an open product, is that you can buy it as an end user, buy it yourself at a fair market price, not a 10 times markup, but at a fair price from a supplier or a distributor.
Yes.
I'll put a plug in for one of our members, Ingenuity Systems, who's a distributor, and they sell many of these products. In fact, I think you can probably buy a variety of these things through them and through other open distribution at a fair price without having to have a contract or a dedicated relationship with the vendor of the product, which has been a problem in the open systems market for a long time. Okay, moving on, a couple more questions. So I'll answer this one. Is the recording going to be available and also the slide deck? Yes, we'll be posting a PDF of the slide deck as well as the recording and the handouts, which is that white paper, along with the data sheets. Once we collect all of that, we'll add all that in. Let's see. So one of the questions, a good question, how does all this integrate into a native LON network? I don't see any native LON devices within this example. Will this only work with a JACE? So there's a couple of different questions in there. But talk a little bit about a native LON device that's running on FT or even IP. How does that integrate?
Yeah, so it's really no different. And you can use a JACE or you don't have to. It's really up to you. So as a native LON network, you can commission these in, let's say, LNS, whatever LNS management tools you use. We happen to use IZOT commissioning tool, IZOT CT, and it works great in those. No different than any other LON device. And you can integrate it with the JACE at that point, or you can integrate it with a smart server, whatever you're using for your HMI. It's really no different. It only changes when you decide to tie it into BACnet, and then it's really okay. What BACnet interface am I using, and how do I discover devices in that interface and pull the devices in? And, that's all platform specific. So yeah, the LON side doesn't change at all.
Mm-hmm. Okay, so along the same lines, when you set up a network with LON devices and you use the LON maker or what is it, IZOT CT, I still haven't gotten used to that name, but the thing that makes your LON network, now you're using the same tool to make your BACnet network. So it becomes a BACnet managed network with a single database tool. Can you talk a little bit about how the addressing works on in this environment for BACnet MSTP?
Yeah, so for BACnet MSTP, addresses are set using physical dip switches. So you cannot use a managed solution to address MSTP. You can, and you do, I would say, use a managed solution to address BACnet IP devices as you commission them. Let's say an IZOT CT, an IP address, a correlating IP address is assigned to it, which becomes the BACnet IP address as well. It's LON IP and BACnet IP. It's using the same IP stack, same IP addresses.
So in essence, the network management tool, once you've assigned the BACnet dip switch address, the network management tool can capture that and actually create a database, just like you would in LON, of your subnet node and node ID in a database. So you basically have a kind of a backup of your system management. Is that accurate?
You don't need to set the device address, Ron, if you're going to be BACnet FT. If you're going to be BACnet MSTP, yes.
Yeah, that's what I thought.
They can manually set the IP address, but again, if you use a management tool, it'll automatically set it.
Right. So I guess the question becomes, I'm trying to translate this question. When you build a network that has BACnet MSTP, BACnet FT, LON FT, BACnet IP, and LON IP, is the eventual resulting database of everything when it's done capture all the network management information, such that if you had a failure and you needed to redo it, you have something that gives you a backup that you can rebuild the network?
Except for the MSTP.
Yeah, it will do everything, but MSTP is not captured. That is set only through physical dip switches.
So, all right, okay, then so you still have the physical dip switch, and even though it has a physical dip switch, you can't capture the MSTP address logically.
If you were to, it depends on how you write your application. So these are fully programmable controllers, right? You can access both the baud rate and the MAC address and the network number over the network if you set up your application that way. Typically, that's not something we've done, but you certainly could. And if you did do that, then yes, you would have all that in the data. Right.
Okay, all right. I think that kind of gets to the gist of the question, which is, in essence, a network management question. Let's see. Got two more questions here. Is LonFT fully working on the IZOT router?
Yes, yeah. It works as a LON router. Yeah.
Okay, all right. So I think that was, yes, the answer to that, certainly. Let's see, one last question here. Yeah, so this is going back to that BACnet priorities. Understanding BACnet priorities would be a good thing to know. I think that's a follow-up question. That's a very good question. It's come up a couple of times here. So we'll take that on, and maybe we can post the answer on the website once we dive into that, so we realize that that is a question people have. And I would say for the two people who asked that question, you guys are still on the line, just send me a note directly, Ron at lonmark.org, and we'll follow up with you, get some more information, and probably put you in touch with the right technical person to learn more about that. I personally would like to know more because it is an important piece. So just send me a note, we'll follow up with you, and as we learn more, we'll add to maybe to that white paper a little bit. And you're welcome. And here's the confirmation. So that was the end of our questions. For the over 150 people that were on the call today, thank you. I know more than half of you are still on the call, which is fantastic. Thank you for participating. Again, we will post the webinar as soon as we get it processed and converted and build the web page for it. So give us a couple of days. You'll see an email with whatever email you used to register today. And I want to give a big thank you to Alan and Sammy and all the folks at Western Allied. You realize Western Allied is an integrator. They're not a vendor. That they don't really get anything out of doing all this work. But because of the nature of the technology and their customer base, the ability to do this and to get more people engaged in working with both BACnet and LON and understanding the synergies is a tremendous advantage to the market worldwide. So again, I want to say thank you very much to both of you for that, and also a thank you to Smart Controls, Adesto, EBAC, Tritium, and to Gesitech, and also to Megachips for supplying the products and the core technology that we showed today. Hopefully next time we do this, we'll double or triple that list, and there'll be more people engaged. So we are planning more webinars. We will do another webinar on the HDPLC, the high definition power line. We'll be doing one on the new LON ISM RF radio frequency channel, and maybe even add that into the demo so that you can see how that all might work together in one cohesive network. Look for that over the next couple of months. And for those of you in Europe that are still awake, there's the ISH trade show next week. You'll be able to see this exact same demo live at ISH in Frankfurt, Germany next week. So make sure you stop by the LonMark booth for that and see how that goes. And again, if you have any questions for any of us, just drop us emails. They're up on the screen here. Sammy and Alan, any closing thoughts?
I think just thank everybody for taking the time out of whether it be their morning, afternoon, or evening. And again, I think we just want to reiterate that we are extremely enthused about this technology, and and it isn't like we're just starting to implement it. We've been implementing it now for almost 2 years.
Excellent. Okay, thank you all very much. We'll end the webinar there, and enjoy the rest of your day or evening.
Thanks, everyone.
Thank you.
Thank you. Bye-bye.